In this video, we are going to be looking at conditional probability. Conditional probability is calculated assuming an event has already occurred or given a hint that a scenario that limits the scenario. So there's two ways that this conditional probability stuff is triggered. An event has already occurred, or we have a hint that limits the scenario. So we've actually already looked at some of these in previous videos. We just haven't really called it conditional probability. An example might be, for the first part, that an event has already occurred is, what is the probability that I draw a king from a deck given I have already drawn a king from a deck and ate it? So once I drew that first card and ate it, it's going to change the pool that I'm drawing from, and so it's going to change the numbers of the probability. And then as far as the hint goes, that's kind of like the idea of, I have drawn a card from the deck and I have it in my hand, and you need to guess it. Okay? What is the probability that you guess the right card if I tell you that it's a red card? So once you know it's a red card, that eliminates half the deck that you would throw up as a guess, and so it's going to change the probability of you guessing that card correctly. All right, that's the idea of conditional probability. Let's write out some examples to make sure we're tracking. What is the probability of drawing a red card, assuming I've already drawn the Queen of Hearts and ate it? So my little parenthetical and ate it is just to emphasize the fact that we've not put that back in the deck. It is gone. So now we have a totally different deck we're dealing with, but this is still just the probability of a single event. I'm drawing one card. Okay, so we're going to build our fraction, and it's just one fraction because it's one event. And how many cards are in the deck? Well, given that the Queen of Hearts has been eaten, that leaves us with 51 cards. And then how many of those cards are red? Well, normally half the deck is red, which is 26 cards, but I ate one of those red cards, so now we're down to 25 red cards. So it's 25 out of 51 probability of drawing a red card from my incomplete deck. So that's the idea. I do want to caution you guys with these conditional probabilities. These are easy to confuse with probability of multiple events. So for example, what's the probability that I draw the Queen of Hearts, first event, and then draw a red card, second event? But here I'm assuming the first event has already happened, it's in the past, I know what I drew, and I know how it affected the deck. So this is a one event given that one event has already occurred. That's different than mapping out the probability of two future events. Let's look at another example. What is the probability of you guessing what card I have in my hand if I tell you it is a club? So I have one card in my hand and I say this is a club. So that means you're not going to guess the King of Hearts because that's not a club. So it's going to limit the pool. This is the hint way of conditional probability. So an event hasn't occurred. I just narrowed how much you're guessing from by giving you a hint. So there are 13 clubs in the deck. So that's the total number of options. You would no longer have your total number of options be 52 cards, even though there's still 52 cards. I haven't eaten any. But I told you it was a club, so you're not going to guess anything but a club. That limits your population to 13. And then the idea is, well, how many of those would give you what you want? Well, there's only one club in my hand, so you have a 1 in 13 chance of guessing what that club is that I have in my hand. Alright, so those are a couple of examples with cards, and cards make for a good probability questions just because there's a lot of different ones, a lot of different attributes for cards. But now what we'll do is look at a slightly different configuration that doesn't involve cards to make sure we're tracking with what's going on with the conditional probability. So in this example, we have 100 people were asked whether they use Facebook, and the results are given in the table by age. If we select one person at random, what is the probability of choosing someone who uses Facebook given that they are older than 44 years old? So This is actually one of the hint probabilities, and so we're looking at this option here where we're given a hint and it limits the scenario. And that's why I put hint in quotes, because it's not literally a hint. It's just this idea of we're limiting the pool that we're selecting from, so it's going to adjust the probability, versus a scenario that occurs that limits the population. That's kind of the two different scenarios. So in this case, when we say given, that means that we're only working with people who are older than 44, which is another way of saying 45 plus. So there's a total of 19 of those people. And then we're going to choose one of them who uses, what's the probability of choosing one of them who uses Facebook? Well, 16 of those uses Facebook. So that's 16 out of 19 probability. And I want to talk a little bit about this word given, because that's like a weird word. Mathematicians use it a lot, but I think people sometimes struggle with what we mean by that. So you can say, we could say, assuming they are older than 44. So maybe another way to think about it is assuming we are only selecting from 45 plus. It's this idea of given we're only looking at this small piece of the puzzle. That's the idea. So when you see that word given, think given, I'm giving you a hint that we're limiting what we're selecting from here. I don't know if that helps, but I know that in my experience, people struggle with how to handle that word given when we mathematicians rattle it off like it makes sense. So that's the idea with a hint. You can also have these conditional probabilities with a table showed up where it's the first idea that an event has already occurred. So here we have the same situation with 100 people being asked about Facebook use, but now our question is, if selecting two people at random, what is the probability of choosing someone who uses Facebook given, there's that given word again, given we have already selected someone who uses Facebook. Anytime you see that given, you want to think, okay, we're dealing with conditional probability. So this one, it's really tempting to think of it as the probability of multiple events because it says we're selecting two people. But then once you get to the given piece, you find out, oh, we've already selected one of those. So we're selecting two people, but one of them has already happened. So it's in the past. It's locked in. So we're doing one probability, we're just selecting the second person. So selecting the second person, what is the probability that that they use Facebook? Well, and this is just dealing with the total because we didn't limit any of their demographics. So there was a total of 100 people, but we've already selected one. So now we're down to a total of 99 people. And then as far as Facebook use, there was a total of 49 who used Facebook, but we've already selected one of those, so that brings us down to 48. So with selecting the second person, the probability that they use Facebook is going to be 48 out of 99. So hopefully you see there how the language of this, while it looks kind of like the probability of multiple events, once you get to that given, you're saying, oh, I already did the first event, so I'm only finding the probability of the second event occurring, assuming this other one has already occurred. All right, so go ahead and give some of these a try and see how you fare.